when you start using your disk to the maximum, okay, so slowly you will see the performance issues. Why you will see the performance issues? Because you're unable to get the continuous blocks over period of time. Okay, initially when disk is completely free, okay, when you try to store any data, you will get continuous blocks. Okay, but okay, over period of time, okay, your disk will be, okay, you will be writing a lot of data into the disk and you will be deleting some data from the disk. Okay, so you'll be writing, okay, reading or deleting, writing, deleting, writing, deleting. So in such scenarios, okay, there is a high chance that your free blocks may get over. Okay, free blocks may get over. Okay, in such scenarios, okay, so what will happen? Your disk header has to struggle to write the data, okay, or to find the continuous blocks, okay, and write the data in a proper order actually. Okay, it has to write some pieces here and there. Okay, so here some pieces, okay, in other place, okay, some pieces, okay, like this. Okay, so you'll not have continuous blocks, so that will cause the performance issue, that will cause the seek time issue. So that is one of the major issue. Okay, so second thing is that need to change the disk whenever my data is growing. Okay, so whenever my data is growing, what I'm doing here, okay, I'm changing my hard disk here. Okay, so this is what, okay, the history we have seen. Okay, every time my data is so every time my data is growing, definitely I need to change my existing hard disk to upgrade my hardware, existing hard disk to the next level of hard disk. Okay, so changing is fine, but okay, one fine day, what will happen? Okay, you may not get the required size of storage, okay, in market. So that's a big problem. Okay, but again, okay, so we all expect that, okay, or every company expect all their data in a central place, okay, to access, for the easy access actually. Okay, for the easy access. Okay, so how to overcome these issues? Okay, so to overcome these issues, Google has identified, okay, Google has given a concept here, guys. Okay, so what it has done? Okay, it created a distributed file system, guys. It created a small software like this. Okay, software. Okay, so this is called as a distributed file system. This is the software they introduced. Okay, so in this software, what they have done? Okay, so they have taken a set of hard disk, guys. They have taken a set of hard disk. Okay, so here, so hard disk one. Okay, like this. Okay, so they have taken, okay, some hard disk. Let's say they have taken 10 hard disk. Okay, out of this 10 hard disk, what they have done? Okay, so they made one hard disk as master disk. Okay, other hard disk as worker disk. Okay, so which one is master disk, which one is worker disk? Okay, who will be having this information? So do you think, okay, the hard disk will know that, okay, hey, I am the master disk. Okay, so this hard disk too will know that, okay, I am the worker disk. Do they know? Do they know?
No.
No, right? Okay, see, these are all hard disk. Okay, they think that, okay, so they are individual components actually. So they are individual. What do you mean of individual components here? What do you mean of individual component? Okay,
It's
see,
not
hard disk is
dependent.
hard disk. Okay, this
It
hard disk
works
is
like
not
a hard
dependent.
disk.
This hard disk is not dependent. This hard disk, okay, this hard disk is not depending on other. Any hard disk is not depending on any other hard disk. Okay, any hard disk is not depending on any other hard disk. Okay, they are all individual hard disk. Okay, but okay, so here this is the system, okay, which is combining all these hard disks, guys, which is combining all these hard disk into a one common place. Okay, so here, okay, suppose, okay, if I ask hard disk, okay, what is your name? It will say, okay, my name is hard disk. What is your name? My name is hard disk 2. Okay, my name is hard disk 3. But if I ask, okay, what is this one? Okay, this is my team. Only this software or distributed file system will feel like this is my team. Understand? Understand, guys?
Yes, sir.
Guys, okay, are you able
Yes,
to
sir.
follow me?
Yeah, follow.
Sir,
Yes, sir.
Okay, see, let us take this scenario. Okay, so there is a team, guys. There is a team. Okay, so there is a team. The team, okay, you take cricket team only. take cricket team only. Okay, we have Kohli, Dhoni, Rohit Sharma. We have different people. Okay, so if I ask, okay, this is the team. Okay, so this is the team member one. Okay, or member one, member two, like this. Okay, so you'll have total 11 members. Okay, you have 11 members. Okay, so if I ask member one name, what is your name? You will say my name is Kohli. Okay. Otherwise, if I ask, okay, who are you? Okay, you will say Kohli. If I ask, okay, member two, who are you? I am Rohit. Okay. Okay, who are you? Okay, I'm okay. Let's say someone else. Okay. Um, what name I can give?
KL Rahul.
Rahul. Okay. Okay. If I ask individual person, okay, they'll say I'm Kohli, I'm Rohit, and I'm Rahul. Okay. If I ask coach, okay, if I ask coach, okay, what he will say? Who is he? Okay. So who is he? Okay, captain. If I ask, okay, who is he? Okay, so otherwise I'll put Rohit here. Okay. So Rahul here. Okay, Kohli here. So if I ask, okay, coach, okay, he will say, okay, he is captain. Okay, he is vice captain. Okay, he's the batsman. Okay, he is a bowler. Okay, bowler. Okay, okay. So this is okay. Like this. Okay, so coach will say that. Okay, so okay. If I ask Rohit, who are you? Okay, he will say, I am Rohit. Okay. If I ask coach, okay, who is this guy? He will say captain. So it means, okay, in the same way here, see, this is the software which is combining multiple hard disks into single team. Understand? Multiple hard disk into single team here. Okay. That single team is called as distributed file system. Understood? That single team is called as distributed file system. Okay. So now, okay, only this software will understand, okay, who is master disk and who are the worker disks. Understand? Understand, guys? So each hard disk, okay, they don't understand, okay, hey, I am the master disk, I am the worker disk. They don't understand. Okay. Only the software will understand this is the master disk, these are the worker disks. Clear?
Yes, sir.
Clear, right? Till this? Till this, I hope, okay, it is clear.
Yes,
If you have any questions, okay, you tell me. Okay. So now, okay. So what software is doing here? Okay, this software is doing the actual work here. Okay. Now software knows that, okay, this is the master disk. Okay, and these are the worker disk. Correct. So this is the master disk and these are the worker disk. Software only knows this one. Will you agree with me? Okay. What software is doing now? Okay. Software is keeping the, so, okay, software is making this entire thing as a storage, single storage. Okay. Single storage. Okay. So as per software, this is a single storage. Okay. So, but okay, here, okay, each hard disk, okay, will have, okay, FAT and, okay, so metadata area, actual data area, correct? This is 10% and this is 90%. Yes or no?
Yes, sir.
Each hard disk, okay, will have, okay. Yes, I'm explaining because yesterday somebody asked, okay, sir, I am not completely clear on this concept. Okay. So that's the reason. Okay. So it means, okay, each hard disk, okay, will have metadata area 10% and actual data area 90%. Yes or no? Okay. This is clear now. Okay. But now, okay. Okay. So I will do one thing, okay, here. Each hard disk, okay, will have metadata area and actual data area. Okay. So metadata area will be 90%. Okay. Okay. And okay. Okay. So actual data area will be, okay. Okay. Metadata will be 10%. Actual data will be 90%. Okay. So only this software knows that, okay, only this software knows that, okay, this is a master disk. As per software, this is a master disk. As per software, these are worker disk. Okay. So now, okay, This entire team, as per software, this entire team is a storage. Okay. So when I say storage, what you will have? When I say storage, any storage will have. When I say storage, any storage will have metadata plus actual data. Right? Any storage will have metadata plus actual data. Will you agree with me? Okay. So now, okay, what okay, this software is doing, okay, whatever data you are storing, that data's metadata will be storing in the master disk. Okay. So see, are you able to understand that
Yes, sir.
data's
Yes,
that
sir.
data's metadata, whatever data you're storing into this one, okay, that data's metadata here. Okay, so this is distributed. Okay, this is called as distributed storage, correct? Okay, so here in this disk, okay, it will store, okay, distributed storage. Okay, metadata will be stored here. Okay, in the master disk. Okay, in the master disk. Okay, here, okay, distributed storage actual data will be stored across here. Understood, guys? Now,
Yes, sir. Yes, sir.
Yes, sir.
okay, so here, okay, so it is entire. This software is treating entire this one as a entire this one as what is it?
Storage.
One single storage. Okay, one single storage. Okay, and what it is doing here? Single storage. In this, okay, one hard disk is taking as master disk, and other hard disk is taking as worker disk. Okay. So what this software is doing? Okay, whenever you store any data into this software, the software, okay, is storing that the data's metadata in the distributed storage. Okay, and this actual data in the
Yes.
worker disk. This metadata in the master disk and okay, actual data in the worker disk. Understood? In the olden scenario, if you see, so in the olden scenario, if you see, the metadata plus actual data both are in the same place. Yes or no? Okay. But okay,
Yes,
in case of this one, okay. So here, okay, I'll put okay, one more error here by connecting these two. Okay. So in this picture, what is happening? Okay. This entire team is like a storage. In this, okay, one hard disk is storing this distributed storage metadata here. Okay. And this distributed storage actual data is stored in different hard disks. Tanuja, you understood? You bring me a study.
thank you. Yes, sir.
You understood right now?
Yes, sir. Thank you.
Okay. So whatever data you write here, okay, let's say I'm writing, okay, here, okay, so I'm writing sample1.txt, which is a 256 MB. Okay. So what this software will do, okay, software will think, okay, this is my entire storage. Okay. So it will cut the data into pieces and okay, it will put the pieces into a different disk here. Okay, different disk. Okay, and it will update the metadata in the metadata disk. Understood? Okay, so now as per metadata disk, okay, as per each hard disk, okay, this metadata is a file. Yes or no?
Yes, sir.
The hard disk doesn't know this is a distributed storage metadata. Okay, this hard disk doesn't know that okay, this is the distributed storage actual data. Okay, so here the distributed storage metadata is a file. File is a file as per okay hard disk one. Okay, so here in the same way, distributed storage actual data is a as per hard disk. Understood? Only distributed storage, okay, this software will understand, okay, so this is the metadata, this is the actual data. Okay. Okay. But each hard disk will not, they see for a hard disk, okay, what is this one? What is this one? For a hard disk, this is just a file. Are you clear? So what they have done, they just separated the, okay, they just separated the metadata and actual data. They combined multiple hard disk into one unit. In that one unit, okay, so what they have done, they started storing the metadata in a separate disk and the actual data in a separate disk. Okay, this is what they have done. Okay, now one beauty here is that, okay, suppose, okay, if you feel that this worker disk are becoming full, you can add, okay, n number of worker disk. Okay, unlimited worker disk you can add. So there is no limit at all. You can add 1 lakh, 2 lakh, 3 lakhs, 10 lakh worker disk also you can add. Understood? Okay, so in this scenario, do you have any fear that, okay, so my logical storage, okay, will become full? Huh?
No, sir. No.
If your logical
No,
storage
sir.
is becoming full, you
No.
add some more
No,
disk.
sir.
Yes or no?
Yes,
Yes,
sir.
sir.
You add some more disk. Okay, so you have an option. Okay, you have a feasibility to add more and more disk. Okay, to this logical storage. Okay, so this is what, okay, they introduced this. Okay, who introduced this concept? This concept was introduced by Google.
Google.
Okay, yeah. Okay.
Sir, one doubt, sir.
Yes, sir.
Sir, in worker disk, metadata, what it's storing then?
What is worker disk metadata? See what I told here, distributed storage actual data. So see, what is this block 1, block 2?
This is file.
This is the actual data of, actual data of your distributed storage, correct?
Yeah.
Yes, sir.
Okay, so okay, sir, very simple, sir. Okay, I have two people, sir. Okay, I have, okay, Ravi, and okay, I have Ramu, and I have, okay, Raja. These are the three people I have. Okay, these are the three projects I have. Okay, so now there is a person here. Okay, so there is a client here. Okay, when I say client, okay, what normally what you think? Okay, let's say foreign person. Okay, so we have a client here. Okay, so this is Venkata here, actually. Venkata here. Okay, so client has given a project to Venkata. Client has given a project to Venkata. Okay, understood? Okay, so this is the project. Okay, so this is the project 1. Okay, which contains, okay, so 3 modules. Okay, so Venkata has given okay, so Venkata has got a project 1 from client, has handed over one project to Venkata, and he told Venkata, hey Venkata, you complete this project. Now what Venkata has done, okay, Venkata has divided this project into, okay, modules. Divided this project into modules. Venkata divided. Okay. See, client gave project 1 to Venkata. So what Venkata has done, okay, Venkata has divided the project into 3 modules, and okay, Venkata has given module 1 to Ravi. Okay. Venkata has given, okay, module 2 to Ramu. Okay. And Venkata has given module 3 to Raja. Okay. And okay, see, now, okay, he maintained a record saying that, okay, so project 1, it has 3 modules. Okay, first module is with, okay, module 1 is with Ravi. Okay, module 2 is with Ramu. Okay, module 3 is with, okay, Raja. Understood? Okay, this is what the information, okay, he is maintaining. Okay, now tell me, will Ravi knows that, okay, so as per Ravi, this is module, yes or no? As per Ravi, okay, he doesn't know it is a project, it is a part of project, yes or no? As per Ravi, what Ravi will think, okay, so Venkata is telling, hey Ravi, I'm giving some work, you do it. He is not telling, okay, project. He's not talking about the project. Okay, I'm telling some work, you do it. Okay, this is the work, you take it and do it. And Venkata is telling Ramu, hey, Ramu, okay, you take this work, okay, and you do it. Okay, and okay, Venkata is telling Raja, hey Raja, you take this work and do it. Okay, so the end of the, what is the project? Sum of these three, correct? End of
Yes,
the
sir.
day, what is the project? Does Ravi know that, okay, this is a piece of project one?
No, sir.
Venkata is not telling. Okay, Venkata is just telling that, hey Ravi, you work on this module. Okay, you work on this module. Okay, you work on this module. Okay, Ravi doesn't know. Okay, this module one is project of project one. Okay, or Ramu doesn't know module 2 is project of okay, part of project one. Raja doesn't know module 3 is part of project one. Okay, only person who knows, okay, all these three projects together is a I mean, all these modules together is a project one. Who knows that information? Only Venkata knows that. Understand? Okay, in the same way, okay, so now client is giving a file to software. Understand? So Venkata is writing, okay, so this is the metadata. Okay, so information about the project. Okay, so this is the information about the project. Sir, no.
Yes, sir.
Okay, so it means how many modules we have, and okay, who is working on what module. This is the information about project one. Okay, so in the same way, we have client. Okay, we have a software. So what client is doing? Client is giving the work to software, saying that, hey software, so I have a file which is of okay, I have a file sample 1.txt which is of 256 MB. Okay, so okay, which is of okay, so okay, 256 MB. Okay, so under this one, okay, we have so under this one, okay, we have okay, we have worker disk here. Okay, what this software is doing? Software is cutting the data into pieces. Cutting the data into pieces. How many pieces you will get? What is the default size of the piece? 128 MB.
128.
Okay? So it will get okay. So you will get okay total
Two pieces.
two pieces.
Two
Okay.
pieces.
So it is putting the piece one here, and it is putting piece two here. Okay. Okay. So can it put okay piece okay, without a name? Can it put okay piece of data without name?
No, sir.
Okay, so for each piece, okay, it is giving some name. Okay, BLK001. Okay, BLK002. Okay, so like this, it is putting in the master disk. It is updating that. Okay, sample1.txt. Okay, has okay 2 blocks. Block is okay. Disk 1 is having first block.
Black one.
So disk 2 is having
Black.
okay. So if anybody see this metadata here, okay, they will understand. Okay, this project one has 3 modules. First module is with Ravi, second module is with Ramu, third module is with Raja. They can clearly understand it by looking at this information. Yes or no?
Yes, sir.
Okay, so by looking this information, can anybody understand that? Okay, sample1.txt has 2 blocks. Okay, the first block is in disk 1. Okay, second block is in disk 2. They can easily understand, right? So this is what is happening, guys. Okay, so here, okay, in the master disk, okay, so here, okay, he has, okay, so his diary, okay, he is maintaining this information. Okay, so his diary is the metadata now. These are the employees here. What is the difference between above example and below example? Both are same, right? There, okay, it is people.
Yes, sir.
They are people. Here it is. These are
Software.
this software.
Sir,
Sir,
in worker disk 1,
okay.
we are storing BLK001 file, right?
Worker disk 1, yes, sir.
What will be the file name of BLK001?
The file name itself is BLK001.
In metadata of worker disk. Worker disk will have separate metadata of BLK001.
Sir, okay. So normally inside worker disk metadata, what you will have? File name, right?
File name, yeah.
What is the file name here?
BLK001.
You will have that only. See here.
Okay, sir.
In the worker disk metadata, we have BLK002.
Okay,
In
sir.
this worker disk metadata. Okay, so in this worker disk metadata, let's see. So you will have, okay.
Okay, 001.
001. That is one. Okay. Okay, sir. Fine.
Wow. Understood.
Yes, sir. Yes. Thank you.
Yes,
So
sir.
in this worker, okay, so it means okay, as per this worker disk, okay, whatever BLK001 you have given, it is a file.
Yeah.
Correct or not?
Yes, sir. Yes. True.
Okay.
Yeah. Thank you.
Yes, are you clear now?
Yes, sir. I'm clear.
Okay. Okay. Come back to the theory part now.
Sir, why the data is stored in the disk which is having higher availability space?
Okay. Okay. Fine. Okay. You are a, okay. You are
Instead
a
of
team
storing
leader.
continuous fashion.
No. Okay. I'll tell you one. Okay. So you are a team leader. Okay. Under you, there are 4 people. Okay. So Ravi, Ramu, Raja, Roja. These are the 4 people we have. Okay. Now Ravi has, okay, let's say 4 years experience. Okay. Ramu has 5 years experience. Okay. Raja has okay, let's say 12 years experience. Okay. Now, okay, you have some work to do. You have some work. Okay. You ask, okay, any person, okay, they will do. Ravi also can do your work. Okay. Ram also can do your work. Raja also can do your work. Koji also can do your work. Okay. But to whom you will give now?
More experienced person.
Why are you giving to more experienced person?
Because he'll do work first.
Huh? So your assumption is that okay. Your assumption is that okay. That okay. Okay. So okay, I'll give you one more scenario. Okay. So if all are free, okay, free. Okay. If all are free, normally you select a person who has more experience. Okay. You will do the work to Roja. Yes or no?
Yes, sir.
But okay, let's say Ravi is free. Okay. Rama is okay occupied. Okay. Raja is free. Okay. Roja is also occupied. Now tell me to whom you will do the work.
Raja.
Why Raja? Why Raja?
He's
No, compared to
remaining.
all remaining 2 people are already
Remaining-
occupied.
Okay. So here, okay, from the available people, you are seeing who has the more experience. Yes or no?
Yes.
Yes sir.
Yes, sir.
Okay. You are seeing, okay. So in this scenario, you will give it to Raja. But why are you not giving to Roja?
Already she is occupied.
She is occupied. She is occupied with some other work. Okay. So we cannot give work to her. Okay. If we are giving to work to her, okay, when I have some free people, but still giving the work to her based on her experience, okay, maybe it will become delay. She will tell, okay, hey, I already have some work. Okay, I'm in middle of that work. Okay, I'll complete that work and do his work. Correct.
Yes, sir.
Yes.
Okay. So now think like this. Okay. This is the situation. Okay. Now tell me to whom you will give the work. You don't have option now.
Ravi.
Ravi. Okay. So in the same way, even okay, when it comes to disk also, so whoever is having more storage, that is like the more experienced. Got it? Okay. In
Okay,
this
sir.
scenario, why I'm storing okay my data into these 2 disks only. See, I can put this block 1 okay, even in this also. I can put block 2 in this also. But why I put it here only? Because okay, these 2 are the disks compared to all other disks. These 2 are the disks having more space. Got it?
Yes, sir.
Clear. So end of the day, see, as a leader, what you will see, you want to complete the work in an efficient way. efficient way. Okay. So what is that efficient way? So you should identify. Okay, you have multiple options. Okay, you have Ravi, Ramu, Raja, Roja. Okay, these are the people you have. Out of these people, okay, so you need to understand who has more experience and okay, who is free also. Okay, based on this one, okay, you will give the work. They are also in the same scenario. Clear?
Yes, sir.
Yeah.
So it means that in the logical algorithm, it will be defaultingly giving an instruction to occupy the free disk first, right?
Exactly. Occupy the free disk first.
Yeah. Thank you.
Understand? Okay. It is not occupy the free disk first. Okay. So who is having more free space? You put the data into that.
Yeah, yeah. True.
Got it?
Yes, sir. Yes, sir. Thank you.
Yeah. Okay. So now, okay, so here, okay, this is the concept of okay, they have, what if we maintain centralized file like a stable across multiple disks with large block size? Okay. So here, okay, these two are the problems. One is the seek time is the problem. Okay. And second one is, okay. So whenever you are, okay, whenever you are, what to say, whenever your data is, okay, you are changing this, you're upgrading your hard disk. This is the problem. Okay. So to avoid this problem, what they introduced, okay, they introduced a concept, okay, concept which is called as, okay, okay, concept, okay, where okay, you combine multiple hard disk into one single storage, logical storage, multiple physical hard disk into a single storage. Okay. Okay. And okay, so in that okay, you maintain one as master disk and others as worker disks. Okay. So in the master logical storage, okay, you cut the data into pieces, put the pieces into worker disk, and okay, maintain the metadata in the master disk. This is the concept. Clear? Okay.
Yes, sir.
So now, okay, so what this concept is called? Okay, this concept is called as distributed file system. This concept is called as distributed file system. Okay. So what is distributed file system? Let us understand here. Okay. When a data set or file outgrows the capacity of a single disk, when you cannot insert your data into a single disk, okay, it becomes necessary to split and store the data across multiple disks or servers. Okay. So you have some data. Okay. You are unable to fit the data into single hard disk. What you will do? You will divide the data into two pieces. Okay, you will put half of the data into disk one, half of the data into disk two. Yes or no? Okay. So this is how you will put the data. Okay. So now, okay, see, when a file system that manages the storage across a network or disk from a single system or a different machines is called as distributed file system. What is distributed file system? Distributed file system is a system. Okay, system which is built on top of multiple hard disk. Okay, so which is built with a set of hard disk. Okay, a network of disk, okay, a set of disks actually. Okay, so okay, now they introduced distributed file system. Okay, so do you think distributed file system will solve this problem? These two problems. What are the problems we discussed? These are the major issues, right? We discussed. These are the major issues. Now, question is that okay, will this distributed file system be able to okay, solve our issue, performance issue? Okay, so we will see this. Okay, we'll see now. Okay, now okay, I have 1 GB of data, or I have okay 1 GB means okay 1024. Okay, 1 GB of data, nothing but 1024 MB of data. Correct or not? This is my data. Okay, sample1.txt. This is the data. This is the data. I have the size of this file is 1 GB, which is nothing but 1024 MB. Okay. Now I am putting it a single disk, single hard disk, writing entire data into single hard disk. Okay. So when I write entire data into single hard disk, okay. So it means, okay, entire work, okay, single hard disk. So now this single hard disk will be able to read, okay, will be able to, so writing here. Okay, the single hard disk will be able to read, okay, write 100 MB per second. The speed of this hard disk is, what is the speed of this hard disk?
100 MB per second.
Okay. So you are writing a data into one hard disk. Okay, this hard disk capacity is 100 MB per second. It means it can write data with 100 MB speed. Okay. Now tell me, to write entire 1 GB data, how many seconds it will take?
10 seconds.
10 or 10 means like 1000 MB, right?
Yeah, almost. Yes,
10
sir.
point, okay, so 10.3 seconds it will take. Yes or no?
Yes, sir.
I take it round figure, 11 seconds it will take. Yes or no?
Yes, sir.
Okay. It will take 11 seconds. Okay. So what in case, okay, so I have a distributed file system, okay, which has, okay, so writing, okay, so writing on, okay, let's say 5 disks. What is the capacity of each disk? 100 MB per second. What is the speed of each disk?
100 MB per second.
Okay. Now tell me how much time it will take?
2 seconds.
Huh?
2 seconds.
Why 2 seconds?
Parallelism comes into picture.
So it means, okay, so now, okay, okay, so, okay, your data will be divided into 11 pieces, okay. So first 5, okay, each disk will write one piece first, okay. It means 5 are gone, okay. So it means, okay, this is piece 1, piece 2, piece 3, piece 4, piece 5. So here, okay, 4, 5, 6, 7, 8, 9, 10, 11, okay. So here it is taking 11 seconds, okay. 1 second, second. 11 seconds. Okay, so here 100 MB, 100 MB, and the, okay, so in the last second 24 MB. It means it is taking 11 seconds. It is taking. Okay, but now I have 5 hard disks actually. Okay, I have 5 hard disks. Okay, so here disk 1, okay, disk 2, disk 3. Total 5 disks. Okay, so what it will do, all the 5 disks will run parallelly. Okay, so here, okay, so here 1 second, first second itself, okay, all the disks will run, right? All the disks will run. Okay, so each disk will write 100 MB per second. This is the first round.
Yes, sir.
The second round,
Same.
this is the second. Okay, one more second. Okay, second. Okay, now one more second. Okay, here it will write 24 MB per second. Okay, overall, how much time it is taking altogether? Okay, how much time they are taking? Okay, you take instead of 1000. Okay, I have, okay, 1000 MB guys. Okay, nearly 1 GB file. Nearly 1 GB file. Okay, 1000 MB. Here it is taking. Okay, here it is taking. Okay. Okay. Here it is taking
10 seconds.
10 seconds. Okay. So here it is taking
2 seconds.
2 seconds. Okay. So what in case if I have, okay, 10 disks, guys?
Within 1 second, work will come. Will be complete, sir.
Okay. Have 10 disks. Okay. So each disk can start, okay, at the same time. Okay. In 1 second, everything can be completed. Correct or not?
Yes, sir.
Okay. So it means, okay, if I have single disk, it is taking 10 minutes. Okay. If I have 10 disks, it is taking 1 minute or 1 second. Yes, sir.
Yes, sir.
Okay. So let us see the example here, guys. Okay. So here, what are the advantages of distributed file system? Okay. Let's say we have nearly 1 TB of data. Okay, let's say, so here 1 TB of data. Okay, 1 TB of data, which is 1000 GB. So the data write speed with the write speed of 100 MB per second. Okay, so now if I have only one server, okay, and one hard disk, if I want to write an entire 1000 GB into this single hard disk, it is taking 175 minutes to write. Okay, so it means, okay, I have 1000 GB of data, 1000 GB of data. This is my data. Okay, I have single disk. Okay, the speed of this one is 100 MB per second. Okay, so if the speed of disk is 100 MB per second, if I want to write a total data, it will take 173 minutes. Okay. Which is another 173 minutes means all nearly hours. Yes or no? Nearly 3 hours. 180 minutes means 3 hours, right?
Yes,
Yeah,
sir.
60. Okay, so nearly 3 hours time it will take. Okay, but now, okay, I created a logical storage with a combination of 10 servers or 10 disks. Okay, each disk can go with the speed of 100 MB per second. Now tell me, if all 10 disks started writing parallelly, okay, what is the maximum speed I can achieve? So since you have single disk, okay, max speed.
So 100 MB per second.
Okay, so here, okay, so speed. Okay, this is max. Okay, speed. Okay, so here, what I can say, okay, total speed. Here, since it is only one disk, okay, total speed also 100 MB per second. Okay. But here I have 10 disks. Each disk can write with the speed of 1000 MB per second. So if all 10 disks write parallelly, how much MB I can write parallelly?
Approximately 1 GB per second.
Nearly 1 GB per second. Okay, so it
Yes,
means that time has been reduced to, okay, 17.3 minutes. Okay, it is nearly 18 minutes. Okay, 18 minutes. Okay, so now, what in case if I have 100 disks, guys, the speed of each disk is 1000 MB. Okay, how much data I can write again? A minute per second? 100 into 100 MB per second. Okay, if all disks, okay, work parallelly, 10,000 MB per
Almost
second I
1
can
TB.
write. Okay,
Almost
almost 1 TB I can. Okay, 10 TB I can write. 10 GB I can write.
10 GB, sir.
Okay, so here
1.73 minutes.
1.73 minutes. Okay, which is equivalent to, okay, which is equivalent to 2 minutes. Yes or no?
Yes, sir.
Okay, so it means, okay, what in case, okay, if I write, okay, 1000 disk, each disk speed 1000 MB. If all 1000 can work in parallel, it will take, okay,
2 seconds.
it's like, okay, 2 seconds, sir. 0.1173 minutes.
Two
Just nearly 2
seconds.
here, guys, okay, how the speed is, okay, reducing. The more disk you have,
The performance is
see,
Speed
more.
also
now tell me, you have a system. Okay, you have some data to write. Okay, so you have one system which is taking 3 hours. You have one system which is taking 2 seconds. Which one you like?
Second one.
2 seconds.
Obviously, 2 seconds, system which is taking 2 seconds. Okay, you cannot wait. Okay, just to write your data, you cannot wait 3 hours to time. Correct.
Yeah.
Yes, sir.
Sir.
Okay, so do you think that, okay, so we are getting very good performance? Huh?
Yes, sir. When compared to the
Compared
single
to
system,
single
it is
system.
Yes.
good
Okay.
performance.
Compared to the single disk concept, okay, so multiple disk, okay, in under one distributed file system, okay, multiple disk under logical storage is is giving far better speed actually. Okay, so now tell me, okay, by adding more and more disk, okay, can you avoid these performance issues?
Yes, sir.
So this is what the problem, right? With single disk, okay, we have performance issue. Single disk, okay, we have performance issue. Okay, this is the problem. Okay, but now, okay, by adding more and more disks, okay, in one place, okay, you're able to achieve super duper performances actually. Do you know what is the maximum performance? Okay, there's a test done. Okay, you know what is the maximum performance? Okay, this can give. Huh? Understood, sir? In a test. Okay. So this concept has given a speed of 4.8 TB per second. Now show me one technology in the world, even today, including cloud. Okay, show me one technology which can write data of 4.8 terabytes in 1 second. Understood, guys?
Yes, sir.
Yes.
So here it is just a case of your data will be split into small pieces and okay, stored into different hard disks. And end of the day, the metadata is updated in the master disk. Okay. So now, with the help of this distributed file system concept, okay, we are able to solve the performance issues. No more performance issues like single hard disk. Understand? Like single hard disk, okay, no more performance issues. Here, please be on mute, sir. This is the maximum speed. Okay. So now, what is the other problem? What is the other problem we have? Need to change the disk whenever my data is growing. Okay. Here, do we need to change the disk?
No, sir. If it is required, we can add it.
Okay. So here, you no need to change any disk actually. Okay. So let it be. Let old disk be with the size of 1 TB and new disk be with the size of 5 TB, 6 TB. Okay. So whenever you feel all the disks are almost full, then what you need to do? You add one more extra disk. Automatically, free space will be added here. Okay. So these are the problems solved now.
Yes, sir.
Definitely yes. Okay. So these are the major issues, guys. Okay. So sometime in 2003, okay, Google, okay, is a search engine, okay, which is Pawan, why you unmuted? Actually, I muted you. Why you unmute? It is creating noise. If you want to talk, just okay, you open and talk. Okay, I mean unmute and talk, and okay, just you're done. Okay, you mute it. Okay, it will disturb okay other 60 plus people actually. Okay, please. Okay. So all the major issues are resolved here. Okay, so performance also they're getting very good performance. It is not good performance. Okay, okay, top or excellent performance you are getting. Okay, and second thing is that okay, you don't need to worry about the changing of hardware every time. Okay, whenever okay, you feel that okay, the logical storage is becoming full, you add one more storage, one more disk to the logical storage. Okay, so these are the advantages. Okay, but okay, see, we understood the advantages, but do you think we have any disadvantages also? This, huh? Do you think we have
Cost
any
increases.
huh?
Cost.
Okay, if you are okay, sir, I'll give you one example here. I'll give you one example.
Random distributed of data.
No, sir, no. Okay, sir. Okay, there is a mobile. Okay, okay, 1 GB speed, 1 GB RAM. Okay, coming with for 1,000 rupees. Okay, there's a mobile with okay 12 GB RAM, coming with 20,000 rupees. Okay, what you will buy, sir? What you will buy?
Performance increases. Cost also increase.
Of course, okay. If you want performance, okay. Suppose okay, if you feel that okay, my 1 GB RAM is fine for me, okay, even though it is slow, also I am fine. Okay, even though if it is taking okay, to type one word, okay, it is taking 2 seconds. Okay, I'm fine with it. Okay, so I'm fine with it. Then okay, I will go with this 3000. Okay, but okay, if I type slowly, my girlfriend will not accept. In that scenario,
Second. I will go with second.
you need performance now.
Yes, sir.
So obviously we'll go for, even though it is a bit costly, we'll go for higher.
We'll go for that.
Yeah. So end of the day, what you want, okay? So you want, okay, if you think about cost, okay, you will not get performance. If you think about performance, you have to spend. You have to compromise at cost. Yes or no?
Yes, sir.
Okay. So both are important. Okay? You just need to think, okay, cost and performance. Okay.
Yes, sir.
Okay. Whoever requests performance, they'll go for costly mobiles. Okay. Whoever is okay, then okay, they'll go with normal mobiles. Very simple. Okay. Next thing. Okay. So we have advantages with the distributed file system, but do you have any disadvantages? That's the next question.
If a worker disk crashes or fails, it is difficult to retrieve data.
Sorry?
If a worker disk crashes, then it is difficult to retrieve data which is there in that particular worker disk.
Okay. Very good, sir. Okay.
Maintenance.
Same as
Okay.
of master.
So let us take this scenario. Okay. So think that okay. So here. Okay. So I have these disks. Okay. So here I have a large scale storage. Okay, large scale storage with one master disk and a five data disk or worker disk. Actually, anything data disk or worker disk, anything is fine. Okay. So these are my disk. Okay, these are my disk actually. Okay. So now, okay, I'm writing a file. Yes, I'm writing a file sample1.txt. Okay. Okay, sample1.txt, which has okay. So let us take this movie, okay, Bahubali movie. So which is size is 384 MB. Okay, normal print. You take it like this. Okay. Now, when you store this file into this logical storage, what will happen? This will be divided into 3 pieces. Okay, piece 1, piece 2, piece 3. Okay, what is the size of each piece?
128.
128 MB. Okay, so now you copied this into here. So each piece you have given a name like so not you. Okay, the system has given a name like BLK1, BLK2, BLK3. Okay, so now you copied BLK1 in here. Okay, you copied here, BLK2 here, BLK3 here. Okay, suddenly due to some issue, okay, the disk 2 is down. What will happen, sir?
The data stored in disk 2 will be lost, sir.
So it means okay. So you will see first part. Okay, you don't know what happened during the interval. Okay, and you will see the climax. Yes or no?
Yes, sir.
Is it fine if you watch the movie? If you watch the movie like that?
No.
No, right? You want to watch full movie, but unfortunately, what happened? Because okay, see your data disk is down, worker disk is down. Okay, so that is the reason. Okay, what happened? The second piece is not available now. Okay, our data disk 2, our worker disk 2 is okay. So here, okay, I will do one thing. Yeah, I will change it. Okay. So in this scenario, what happened? Okay, so if second piece worker disk 2 is down, you will not have second piece. Okay. So now if you try to open Bahubali movie, it will give you first piece. Okay. And okay, after some time it will disconnect again. Okay, it will connect you with the climax. So this is one of the problem. Don't you think this is the problem with distributed storage?
Yes, sir.
Yes, sir.
In
This
case
is
of a normal store, if you store everything in a single disk, if disk is available, you will watch full movie. Disk is not available, you will not watch even small. You will not watch a movie, either 100% or 0%. But here it is not like that. Here, okay, I have two pieces, one piece is not there. This is the problem, guys. This is one problem. Okay, with that distributed storage. Okay, but how? Okay, what is the solution for this problem? What is the solution? Okay,
replication.
so this is the problem. Yes, this is the
Replica.
problem. Okay, so this is the solution. What is the solution here? So what you will do now? Okay, so whatever BLK1 you have, you put into two places, three places. BLK1. Okay, so wherever you have BLK2, okay, this also you put into three places. Okay, wherever you have BLK3, okay, you put into this place now. Okay, you put into BLK so 3 here. BLK3, you put it here. BLK3 second copy. Okay. Now BLK1 first piece. Okay. So each piece, what I'm doing, this is first piece. Okay. This is second piece. Okay. This is second piece. Okay. Now this is the third piece. Okay. So first piece. Okay. Second piece. Third piece. Okay. Now if you store like this, okay. Now you tell me, okay. So second disk is gone. Is there any problem for my data?
No, sir. There will be no problem.
Why?
Because the replica is this, sir.
So if second worker disk is not there, what is not available? Block one copy is not available. Block 2, 1 copy is not available. Okay. But do I have block 1 in some other disk? I have
Yes,
here
sir.
and I have here also. Okay. Do I have block 2 in some other disk? Yes, I have block
Yes,
2
sir.
here. I have here also. Okay. So by maintaining this one, okay, by maintaining this one, okay, by this is called as replication, replicating your data blocks. Okay, data replication. Okay. So here by doing the replication, even when disk is gone also, you can still get your piece of data from other disks. Okay. But here, if you maintain one copy itself, okay, if you maintain one copy itself, this is the first copy, one copy here itself. This is second block, this is third block. Okay. If you maintain one copy, what is the total space occupied here? 384. So now 128 plus 128 plus 128, 384. Okay. But here, if I maintain this one, okay, all these three together 384, one copy. Okay. All these three together 384. Okay. And all these three together 384. Okay. Means okay. Total space taken here is okay, sum of okay, this okay, so this integral. Here, if you go in this model, single copy, okay, single copy, total space required is 184 only. But if you go in with the replication, total space required is 1152. So don't you think that okay, you are wasting storage here?
Sir.
Huh?
No, sir.
Yes.
Are you wasting? No. So here, okay, see if you go with one copy, then okay, you are putting only, you're using only 384.
384.
Okay. If you go with 3 copies,
Yes,
okay,
sir.
It will
first
take
copy 3 times. It means okay,
Storage.
384. Second copy 3 times, 384. Third
384.
copy 3 times,
384.
384. So
Here,
it means okay. So here, if you take this one as 100% storage, okay, this is 300% storage. Correct or not?
yes, sir.
You require 100 MB here okay, in this model with replication you require 300 MB here. Okay, so it means okay, are we wasting the storage or not?
Yes.
But the single hard disk, okay, you will put only one copy, one full copy. Okay, will you put second copy, third copy also in the single hard disk?
No, sir.
No, right? Okay. But here, since it is a distributed storage, what we are doing, we are putting the same data in multiple disks.
Places.
Multiple
So
disk.
Multiple disks.
why are we doing this one? To avoid the
Data loss.
reuse, actually.
Data loss. Crash.
Data loss. Okay. So now the next question. Okay. So is it a good thing or bad thing?
Sir, excuse me, I have a doubt actually.
Yes, sir.
Sir, how the metadata of this block one will be stored now in master disk actually? Because we're having three block one, right? Now.
So metadata will be like this actually. Okay. So here, Bahubali, this is the movie. Okay. So here, so BLK 001 in disk 1.
D2, D2.
Disk
Okay.
2, disk 3. Okay. Understood.
Yes, sir. Yes, sir.
Okay. BLK 002. There it is. Disk 2, comma, disk 3, comma, disk 4.
Disk 4.
BLK 003. Disk 1, comma, disk 3, comma, disk 5. Understood now?
So if it knows that it is a copy, it won't combine the data while reading.
Okay. So while reading, what it will do? Okay, now, if I want to read, I know that, first piece is with 3 people.
Yeah,
Yes or no?
Yes, yes.
Yes, sir.
So from whom I will take? Will I take, first piece 3 copies? All 3 copies or, 1 copy is fine?
1 copy is fine actually.
Then out of disk 1, disk 2, disk 3, from whom I will take this copy? All 3 are having the same copy, right?
Whoever free that.
Obviously, yes. Okay, whoever is free. Okay. So I have some work to do. Okay, whoever is free, I'll give to them. Okay, now at the time of reading, I will check these 3 people. I'll check these 3. Okay, whoever is normally, let's say you have, you are a team leader, or you are a manager, you have some work to do, under you 3 people, all 3 can do. How will you choose, who is the correct person to do this one now? Huh? You're a manager, guys, or you're a team leader or manager. Okay, under you, you have 3 people. Okay, all 3 people can do this work. Okay, now on what basis you will select these people?
Experience.
Huh?
Experience.
Availability, sir.
Experience. Okay, think that. So what is the guarantee that the experienced person is free?
Not
You should see the
necessarily.
availability also, right?
Availability, yes.
Yeah.
Yes or no? You should see the availability also. Okay. So if I am a manager, what I will do? I will ping in Skype these 3 people. Okay. Yes or no?
Yes.
I'll ping. Okay. In Skype these 3 people. I'll ping. Okay. Each one separately. Hi. Who will reply me first? Whoever is not having work. Okay. Whoever is sitting ideally reading newspaper, they will reply me first. Okay. If a person is really having work, will he reply immediately?
No.
No, sir.
See, I'm busy with some work. Okay. Even my manager reply also, I may reply slowly. Correct or not?
Yes.
Okay.
Yes, sir.
So, but I'm no work. I'm reading newspaper. Suddenly my manager ping me, hi Venkata. Okay. Hi. Immediately reply. Correct or not? Okay. So this is the scenario. So out of these 3, at the time of reading, it will check who is free, and from that disk it will take. Okay. But now the question is that is it a good idea, bad idea? Getting the data across.
Sir, what if every disk is having same free?
Sorry, sir.
What is the case if every disk is having same free space?
Not free space. Okay.
While reading.
While reading. Okay. So, sir. Okay. How do you check? Okay. Whether disk 1 is available or not? Normally. Okay. So let us take this scenario. Okay. So I have an option to send a mail from Gmail and Yahoo also. Okay. How to take a decision? Okay, whether I go with Gmail or Yahoo. So google.com. Okay. Okay. Now tell me, okay, how much time, okay, this is taking to reply me, and how much time Yahoo is taking to reply me? How will I see, okay, who is faster? See, if it is a person, okay, yes, okay, I can ask, hey, Santosh, are you free or not? Or I can ask, okay, Ravi, are you free or not? Okay, but okay, these are not humans, right? Okay, these are hard disks actually.
Yes.
Okay, in that scenario, how do I understand? Okay, so which hard disk is free?
So average time is
Which is
Right
responding
picking.
more
for MS. This is necessary
fast.
45 minutes per second.
No. So here it is 61 milliseconds, 366 milliseconds. Now tell me, who replied me fast?
Yes, which is responding fast. Google.
Google.
Who is responding fast? Whoever is not having work is responding fast.
Yes. Sir.
Google doesn't have work. Okay, it's not like that, guys. Okay, whoever is responding fast,
Responding
okay.
fast, actually.
Yeah, I will go to that. Okay, so obviously I'll go to Google now.
Okay.
Got it?
Yeah.
Okay, so that's how I decide. Okay, so when I have 3 disks, okay, I will ping each disk. Okay, I'll compare the response time. Who is responding me fast? I'll go to that disk. Very simple. Clear? Or any questions?
Yeah, clear now.
Okay.
Clear, sir.
Okay, but okay, now the question is that, okay, don't you think this is a storage overhead here?
Yeah.
Are we taking extra storage or not?
Yes, it will continue.
Yes, sir. We are taking, but we are not losing any data.
Okay, so but is it a bad thing or good thing?
Good thing only, sir.
Good thing, sir.
Sir,
Good
from
thing
data
only.
point of view, it's good only. From cost increments point of view, it will be.
But what is important, sir? Money is important or data is important?
Of course, data.
Data is important, sir.
Of course,
Data is important. Okay. So if you ask me one simple example, guys, okay. So let's say you have some childhood photos. Okay. So normally for any person, okay, childhood photos are okay, precious, right? Like very important, right?
Yeah.
Yes or no? Okay,
Yes.
let's say have all your childhood photos. Okay. So 100 MB. Okay. So now what you will do to safeguard this one? What you will do? You will put a copy in your laptop. So you have one copy of this childhood photos in your laptop. Okay. Now you may get it out again. What in case, okay, if I'm at my friend house and, okay, I don't have laptop, and he is asking, if he asks, okay, show me your childhood photos, how can I show? Okay, I may get a doubt. Okay, what in case if my laptop is crashed? I will lose all my childhood photos, right?
Yes.
Okay. So for that, what you will do? You will take, okay, you will take one more copy in external
Disk.
hard disk. You will keep same photos in external hard disk also. One copy. Okay. And okay, you will keep same photos in. You're also doing the same thing, right? Okay, you have childhood photos, okay, and you are putting one copy in laptop. So this is okay, 100 MB. Okay, second copy in external hard disk, 100 MB. Third copy is Google Drive. So total here also you are spending okay 1500 MB. Okay, so here, okay, are you thinking about the storage? You're not thinking about the storage. Why are you not thinking about storage? Because, okay, see, 1500 MB is not a costly one for me. Okay, but okay, if I want 1500 MB storage, it means, okay, 1.5 GB. 1500 MB means, okay, 1.5 GB storage. If I want, okay, I will get it for 100 rupees max. No.
Yes, sir.
Yes, sir.
But okay, can I, if I give 100 rupees, okay, can anybody give my childhood photos of 100 MB?
No one, sir.
No one, right? So here, what is important? Data is very important than your storage. So here also it is the same case. Okay, even though it is 3 times here. Okay, end of the day, data is important than anything. Clear? Okay.
Yes, sir. Clear, sir.
Okay. So what are the advantages we have seen? So we have some advantages. Yes, okay. The speed is one advantage. Okay. So lightning speed. Okay, 4.8 TB per second. Okay. So even okay, if all flights in the world they started traveling together also, all flights in the world. Okay, see if one flight start from per hour, okay, on average how much data one flight will generate? One flight also okay per hour, okay. So on average
10 TB.
3 TB of data on average. Okay. So now how many flights okay we may have in the world?
Many, sir.
Sorry?
Like, many flights will be there.
Many,
Sir.
right? Okay. Even okay, all the flights okay travel okay. This is okay 3 TB per hour. So if many flights travel together also, okay, this distributed system can store the data without any failure. But do you have a system okay in the world okay, okay, in the world okay, which can manage this, which can store this much data per second?
No, sir. There is no single system.
Yeah. Okay. There is no single system which can manage this speed. Okay. In fact, okay, see, I just give an example. Okay. Say the more and more disk you add, okay, the performance will be more and more. Got it?
Yes, sir.
Okay. Yeah. Okay. So now let us slowly enter into Hadoop side cases.
Sir, but if master hard disk will fail to work?
Very good, sir. Very good. Okay. If master hard disk is failing, okay, I will have pieces, but I don't know which pieces relate to which file. Yes or no?
Yes, sir.
So this master hard disk is very, very important here. Master hard disk is very, very important here. Okay. In this scenario, okay, block 1 is in data node. Disk 1, block 2 is in disk 2, block 3 is in disk 4.
We can have a replica for master also, no, sir?
You can have a replica for master data. Okay. We'll talk about that one. Okay. Very good question, sir. Okay. So, but okay, we will talk about that. Okay. So now, okay, slowly come into this picture. Okay. Now, we understood the distributed file system is a concept given from Google. Yes or no?
Yes, sir. Yes, sir.
Normally,
Yes, sir.
okay, Google companies like Google, okay, they don't always work for money. They work for money for sure, yes, okay, but not always. Okay. So when they find some concept which is very, very interesting, they'll give it to the world, okay, for free of cost. They say, hey, this is the concept we have. Okay. So if you want to add okay more and more features to this concept, okay, you can go ahead and add it. Okay. So now one person felt that okay, this concept is very interesting. Okay. Who is that person? His name is Dog Cutting. Okay. Dog Cutting is the person who felt this okay, this distributed storage, distributed file system. Okay, is a good concept. Okay, so this is from Google actually. This is from Google. Okay, so yes, and Google has given it to the world for free of cost. Okay, so Dog Cutting has taken this concept from Google. Okay, and okay, this is only works for storage. Okay, now he developed some solution. Okay, he developed some solution for okay, distributed storage. Okay, so distributed processing. Okay, so distributed processing. Okay, this is his own concept actually. Okay, so he added he has taken distributed storage concept from Google and he added his concept of distributed processing. Okay, and he released a storage plus processing. Okay, he released the software okay to the world. The name is Hadoop. Got it, sir?
Yes, sir.
Who released Hadoop to the market, to the world?
Okay.
Okay. So now Hadoop is a software, okay, which comes with distributed storage and distributed processing. So now we were telling that okay, we will install some software. Okay, so using some software we do this. Using some software we do this. Okay, we are talking so many things. Okay, from that time, correct?
Yes, sir.
Yes or no? So now you understood what is that software? That software is nothing but your Hadoop. Okay. So now Hadoop. Okay. So when I say Hadoop components, okay. When I say Hadoop, okay. Storage as Hadoop distributed file system, HDFS. Okay. And okay, okay. So actually he started okay processing layer, okay, with a different one. Okay. Yeah. Get another resource. So it has okay, two components now. HDFS, Hadoop distributed file system, which is a storage layer of Hadoop, and again YARN, which is a processing layer of Hadoop. Okay. So when I say HDFS, HDFS is a distributed file system that provide higher performance access. Okay, high performance access otherwise. Okay. How it will provide high performance access, guys? How are you getting the high performance? Okay, with distributed file system.
With
DFS.
parallel writings to the
Exactly.
particular.
So with the parallel writing and parallel reading also. Okay, with parallel writing and parallel reading. Okay, so with these two, you are getting the high performance. Okay, to the data. Okay, but okay, with fault tolerance. What is the fault tolerance? Since you are maintaining the replica of each block, okay, even okay, one disk is corrupted or one disk is damaged also, you can still retrieve the data from other disk.
Yes, sir.
Yes or no? Okay. So here, okay, each file block is stored into 3 disk by default. 3 disk by default. Okay. Clear. So this is how we are getting the high performance access to data with fault tolerance. Okay. And okay, we'll talk about this. Okay. Processing layer. Okay. Later stage. Okay. Slowly. Okay. We'll comment now. Okay. We understood. Okay. Hadoop is a software which has okay both okay distributed SDFS and EM. Okay. Yes or no? Okay. So now guys. Okay. So now.
In short, in short, we need not to have DR in Hadoop systems because anyhow we are maintaining three copies of everything.
Yeah. Sir, okay, what in case okay now okay let's go back to the same concept here. Okay, now okay block 1 is in 3 hard disks. Yes or no? Okay, what in case your time is bad and okay all 3 worker disks are gone, what will happen now?
Then it is a problem.
It is a problem. Then okay, the first piece okay you don't have even one copy also nowhere. Okay, so okay see DR is unavoidable. Okay, so why I'm saying DR is unavoidable? Okay, let's say okay you have a Hadoop cluster set up in one place. Okay, but due to fire accident or due to natural calamities like okay earthquake or any other issue. Okay, what in case if entire cluster is damaged? It's a data loss, right?
Yes.
Even though you have 3 copies, okay, entire cluster is gone.
Sir.
Yeah.
Okay, so that's the reason. Okay, so I'm not saying okay Hadoop. Okay, if you use Hadoop, okay, you don't need to maintain the disaster recovery. Okay, you can maintain. Okay, until okay your environment is safe. Okay, until your cluster is safe. Okay, Hadoop will maintain the multiple copies for you. Got
Okay, sir. Got it.
Yes, sir.
Okay, so now okay, we are understanding that okay, so metadata disk, worker disk. Okay, sorry, any disk can okay. I have a hard disk. Okay, without connecting to a laptop or okay, without connecting to a desktop or without connecting to a server. Okay, will the hard disk automatically work, sir?
No, sir.
I need to connect it, right? Yes or no?
Yes.
Okay. So now let us take it. Okay. So now what I'm doing, okay. So I'm taking, okay. So I'm taking Hadoop cluster like this. Okay. So now, okay, I'm taking server 1, sir. So I'm taking, how many servers I'm taking total? I'm taking
6
6
servers.
servers.
6 servers,
Okay?
sir.
6 servers. Okay. When I say server, normally what? Okay. When I say server, okay. When I say server, okay. What will have in a server, guys? Normally, each server will have processor. Okay. You have some processor, CPU. Processor means CPU. You have some RAM, hard disk, and network. Okay. So this is the scenario of each server. This is the scenario of each server. Okay. So each server is having processor, RAM, hard disk, network. Processor, RAM, hard disk, network. Okay, like this. Okay. So now, okay. Now what I'm doing? Okay, I'm installing Hadoop. Okay. Okay, I'm installing Hadoop in each machine. So I'm installing Hadoop in each and every machine. Are you clear? Any question? If I install Hadoop in only one machine, that is fine. No. Okay. So I will install Hadoop, okay, in each and every server. Each and every server. Okay. So I have total 6 servers. Okay. So first what I'm doing? So first, okay, I will install OS in each one. Okay, I will install OS. Okay. So what is that OS? Linux OS. I'll install Linux OS. Okay. Each and every machine. Okay. On top of that, okay, you'll install Hadoop. Okay, you'll install Hadoop. Okay. So now when you install Hadoop, okay. Okay, so I'll install Hadoop. Okay, now, okay. If I install a software, automatically it will take care. Automatically it will take care. Okay, so now, okay, when I install Hadoop, okay, every installation will have some config files. When you install Hadoop, automatically configuration files will be created in each and every machine. Okay. So now in the configuration file, okay, I will tell, okay, in the configuration file, I will tell, okay, who should be, so inside the config files, I will tell here, okay, inside the config files, I will tell, okay, which server should act like, okay, which server should take care, okay, so no, okay, config files, okay. So now these are the config files, okay. Now I installed a software, but okay, without starting some service, okay, will this software automatically work?
No, sir.
Sir, okay, very simple, sir. Okay. So I installed Windows, right, in my laptop.
Yes, sir.
I installed Windows in my laptop. Okay. But okay. Now, if I'm starting, okay, if I'm using Windows means there are some, okay, okay. Yes. Okay. There are 107 background process running. Yes or no?
Yes, sir.
Okay. What are these background processes, guys? What are these background processes? See, Windows processes. What are these Windows processes? Okay. See, to use your Windows, okay, if you install only Windows, okay, that is not sufficient. Okay. So you are switching on your laptop and you are loading Windows means, okay, you are starting some services. Okay. Then only your Windows is working. Okay. In the same way, if I install only Hadoop software here, okay, that is not sufficient. If I install only Hadoop software in this here, that is not sufficient. Okay. So what we need to do, we need to start some softwares, so some services. Okay. Now, what is the service I will start? Okay. So I will start. Okay, so first okay, I will decide okay where I should have okay what is okay which server I should take it like a master disk. Which server I can take? Can I take server one hard disk as a master disk? Okay, so it means okay my expectation is that okay so this server disk should be the master disk. Okay, master disk, and okay this should have central part. This is my idea. No?
Yes, sir.
So this is my idea. Okay, so my server one hard disk is the master disk, and okay this disk will contain centralized part. Okay, so okay if this is master disk, obviously these are all worker disk actually, correct? Yes or no?
Yes, sir.
Yes, sir.
Here this is worker disk. Worker disk which contains data blocks. Which contain data blocks. Yes or no? Worker
Yes,
disk,
sir.
what worker disk will contain? Data blocks. Okay. So here this is metadata and this is actual data. Okay. So now, okay, fine.
So
Okay.
basically, Hadoop is installed in all the systems, but only config file will define
We'll
which is
define
which node.
who should store the master, okay, which is master disk and which is worker disk.
Okay, okay, okay. Got
So
it.
config file will tell, okay, which is okay, config files will tell which is master disk and which are worker disk actually. Okay, are you clear? So now fine. Okay. So
Yes.
since it is starting, okay, it is maintaining server one is maintaining master disk. Okay. Our idea is that okay, server one should maintain the master disk. Okay. So here I need to start a master service then. Okay. So Hadoop is installed here. Okay. When I say Hadoop, okay, it's a combination of multiple services. Okay. So here I'm starting a master service. It is called as okay. My idea is that okay, this should work like a master disk. That is the reason I will start master service. The name of master service is name node. Okay. So here, okay, so here my idea is that okay, all these things should work like a worker disk. Okay, so I will start a worker service. It's called as
Data node.
Data node.
Super sir. So yes, okay. Now, okay. So if I want to make this as a master disk, I should start master service here. Okay. If this is if I want to get this disk as a worker disk, I should start worker service here. Okay. So what is the service, guys? What is the service here? What is the service here? It's a background process. Okay. See, now I am seeing okay desktop. I am seeing some icons here, okay, files here, all those things. Okay. See, I'm seeing all those things here means okay. So there are some background softwares okay helping this OS to show all these things to me. Okay.
Yes, sir.
In the same way, if see, I have servers here. Okay, OS is installed, Hadoop is installed. Okay, but some services should be running on top of this machine. Okay, what is this service? Okay, so here, if you feel like this one, if you want to make like a master disk node, then okay, you should start master service. Okay, so here name node. Okay, so master service is master service. Yes, name node. Okay, worker services. Okay,
Data node.
data node. Okay, master service will maintain. Okay, centralized. Fine. Okay, worker service will maintain data blocks. Correct or not? So it means okay. So entire logical storage file system. Okay. So if I take okay, since this is Hadoop, okay. So this logical storage is called as this logical storage is called as HDFS. Okay. So enter inside HDFS. Okay. So to run HDFS efficiently. So when I say HDFS, So we have SDFS. When I say SDFS, it is a distributed storage. It's nothing but a distributed storage. Okay. When I say storage, it will have metadata plus actual data. SDFS is nothing but a distributed storage. When I say distributed storage, it should have metadata plus actual data. Okay. But here metadata is stored in a machine. Okay, in a machine. Okay. Running with the name node service. Metadata is stored in a machine running with name node service. Actual data will store in a machine running with data node service. Okay. So now I can say that okay, here okay, by looking into this picture, can you say that okay, hey, I have a Hadoop cluster. What is cluster? What is cluster?
Comprised of
Cluster means okay. So set of
Group of
servers. No, servers. Okay, acting like a single unit of team. What is a cluster? What is a cluster? Cluster is like okay, a set of servers acting like a single unit or single team. Here okay, I have Hadoop cluster with 6 servers. Out of these six servers, okay, one server is playing the master role, master service is running with master service. Other servers are running with the worker services. Master service is nothing but your name node, and worker service is nothing but your data node. Okay, so on name node machine. Okay, so since it is running with the name node service, can I call this as a name node machine? Huh?
Yes, sir.
I will call this as a name node machine. Okay, since this machine is running with this server is running with data node service, I'll call this as a data node machine. So it means okay, in a Hadoop cluster, I have one name node, multiple data nodes. Correct? So when I say Hadoop cluster, it is a combination of one name node and multiple data nodes. Okay, multiple data nodes. Any questions till now? Any questions, guys?
Sir, in data nodes, you don't find any metadata, right, sir?
In data nodes, okay. What do you mean of metadata here? Okay. See which metadata? See, centralized metadata. You will not find any centralized metadata.
No. Respect to metadata of that server.
That will be there, sir. Okay. See, hard disk means okay. We have local metadata. You will have local metadata, but central metadata will be there in the data nodes.
No, sir.
So here, okay, whatever it is, okay, you call as a local metadata. So what do you mean of local metadata here? So here I will say local metadata.
4K data details.
Local metadata. So this is each disk will have local metadata. This is common, sir. Local metadata is common. Okay, but okay, central metadata is local metadata will be there in each and every disk. Okay, that you cannot skip actually. But central metadata means metadata of all these all together will be maintained in the name node machine.
So altogether, name node and data node is all considered as HDFS, sir?
Hadoop, SDFS, yes, sir. Okay.
HDFS only.
Exactly. Okay. So when I say SDFS, it's a combination of master nodes plus worker nodes. Okay, it means combination of name node plus data nodes.
So whenever you are installing Hadoop installation, HDFS Hadoop installation, defaultly you will get only a name node and data node, or also you will get a secondary name node.
Of course, yes, sir. Okay, so those that I didn't touch right till now.
Okay. Because here the HDFS comes into picture now, so that's why I'm asking.
Yeah. I will come to that part also, sir. Okay, I'll come to that part also. Okay. So yeah, clear now.
Yes, sir. Clear. Sir.
So name node is the master service, which is running on the master node. Maintain the master disk. So data node is the worker service running on the worker node and maintaining the worker disk. Okay. So now, let me tell you. So how the writing process will work here, data writing. Let's say I have sample.txt. Okay, which is of 12 MB. This is of 512 MB. Okay, I want to write this one. I want to write this file into this storage. Okay, so how the writing will happen here? So whom I will connect first? Okay, so to do this one, I need to type a command, right? Okay, so file copy command. Okay, what is that command? I will tell. Okay, when you type file copy command, so this copy command will invoke a writing algorithm. Yes or no? Huh?
Yes, sir.
Command will invoke a writing algorithm. What this writing algorithm will do now? Will invoke writing algorithm. Okay. So what this writing algorithm will do? Okay. So writing algorithm will contact name node first. You contact the name node. Understood, sir? So writing algorithm is contacting name node and asking, hey, name node. So who is name node here? This is the master service here. Okay. Hey, name node, I want to write. Okay, I want to write sample.txt, which is a 512 MB size. Okay, now what name node will do? Okay, so here, what will happen, guys? Okay, so here each data node service will be sending heartbeat to name node. It means, so here each machine will be sending heartbeat to master service. So here, not server. Okay, so each data node is sending heartbeat to name node. So each data node is sending heartbeat to name node. Okay, now and in that heartbeat, now data nodes will update name node like So you treat it like this case. Okay, so here name node is like a manager, or a team leader, and these are the employees. Okay, so now each data node will update name node saying that how much free space I have with me. Understood? Okay, understood, guys? How much free space I have with me. Okay, so that's the information. Okay, so each data node will send it to name node. Okay, so do you think now name node will have the information, right?
Yes, sir.
Who is having more free space? Correct.
Yes, sir.
Okay, so now writing algorithm will approach. Okay, name node, hey name node, I want to write sample1.txt. Okay, so now what name node will do? Okay, name node will check in the centralized part whether this file is already existing or not. Normally, if this file is already existing, what will happen? Huh?
You'll ask for override.
It will tell file is already there.
Already
This file
there.
exists.
Okay, so file is already there, and stop the command. Okay, so in fact, it may ask, do you want me to overwrite or not? Okay, so if you say no, then it will cancel. Okay, if you say yes, it will overwrite. Okay, there's a different story here. Okay, think that writing algorithm is asking name node, hey name node, okay, I want to write this file, please help me. Now name node will check in the centralized fact whether this file is already existing or not. If it's existing, it will throw error saying that file is already existing. Okay, if not, what name node will tell? Okay, writing algorithm, fine. Okay, so I have information about each and every data node storage. Okay, yes, I have enough space here. Okay, do one thing. Okay, you start right. Okay, first you cut your data into pieces. Okay, first you cut your data into pieces. Okay, so immediately what writing algorithm will do? It will cut into pieces. Okay, how many pieces I'll get now? This one of 128 MB, piece 2, piece 3, piece 4. Total, how many pieces I'll get? 4 pieces. Okay. Now it will cut the data into pieces. Okay. Now it will ask name node. Writing algorithm will ask name node. Hey, must name node. Okay. I cut my data into pieces. Tell me, okay, what is the name I should give to first piece and okay, where to write? Understood, guys?
Yes, sir.
So end of the day, what is the name we should give to each piece? Who will decide?
Name node.
Name node will decide. Okay. So name node is the one who will give the unique block numbers. Okay. Let's say 001. It has given 001 here. Okay. Name node told, okay, so write this into okay. So dn1, dn2, dn3. Okay. So here data node. So okay. This is server 2, right? Okay. Or can I make this is server 0, server 0, server 1, server 2. Okay, fine. Okay, so here this is name node. Okay, so here okay, this is I'm taking like okay, this is data node 1, data node 2, data node 3, okay, data node 4, okay, and data node 5. Okay, so like this case. Okay. So now, okay, so name node knows that who is having more free space, right? Okay, so now name node is telling that okay, so for first piece 1, you give a name BLK001 and put it into okay these 3 machines. Why these 3 machines? Why not
Those
these
are
2?
having more space.
More
More
space.
space.
Okay. So it means okay, put into DN3, DN4, okay, DN5. Okay. So and for the second piece also, okay. Second piece, okay, you put okay this name mostly you put into okay DN2, okay, DN3, DN4. Okay. And third piece, okay. Okay, so you put into you give a name like this, okay. So dn1 comma 2 comma 3, okay. So for the fourth piece you put okay you okay and put it into data node 4, okay, or okay 3 4 5. Okay, so now who is deciding the name of each piece? Name node is deciding. Okay, and who is deciding okay where this first piece should be available? Name node only deciding.
Name node.
Okay, so now name node will tell okay, writing algorithm, write first piece of data in with the name BLK1 in data node 3 4 5. Okay, so now writing algorithm will give this piece of data 128 MB to these 3 these 3 data nodes, a data nodes. Okay, write this data of 128 MB with the name BLK001. Okay, so BLK data node will write data into BLK001 128 MB into this hard disk. We will write this data node 3. Okay, so like this. Okay, so these 3. Okay, next BLK002. Okay, 2 3 4. Okay, so BLK.
So Venkat, BLK001 will be written by writing algorithm in 3 nodes simultaneously
Yes,
at
yes,
a
yes,
time.
yes, yes. Okay, so writing algorithm will give data node service is running, right? So parallelly, sir. Okay, when data node 3 is writing block 1. Okay, so is there a requirement for data node 4 to wait?
No, sir.
All 3 can run parallelly, right?
Yes, sir.
Yeah.
Okay, so writing algorithm will give this piece of data to or all 3 data nodes parallelly. Now each data node service will write into respective hard disk. Clear?
Yes, sir.
Okay. So now block 2 is written in data node 2, data node 3, data node 4. Okay. Now block 3 is written in data node 1, 2, 3. Okay. So BLK 003 of 128 MB is written in 1, 2, 3. Okay. BLK 4.
Ankit, does it have dependency on block one? Once block one is BLK one is committed, then only it will go for second, or it has no dependency on that as well?
No. Okay. Parallel it can go, right?
Okay. So all four chunks of blocks will be written parallelly.
Parallelly, yes, sir. Yes.
Got it. Yeah.
Okay. So now data node 1, 4, 5. Okay. So like this, let's go. Okay. So like this, okay. It has written parallelly. Who has written this one? Is name node writing or okay, writing algorithm is giving to data nodes and data nodes are writing?
Writing algorithm.
Writing algorithm is giving to data node. Data node is writing in its own disk. Okay. Yes or no?
Yes, sir.
See, without this data node service, okay, you should have some service to write the data into hard disk and read the data from hard disk. Got it?
Yes, sir.
Okay. Now, okay. So once work is done, now writing algorithm will update name node. Okay, name node. My work is done. Please update the metadata. Now name node will update the centralized fact. What it will update? Okay. So this is the centralized fact. Okay. So it will update like this. Okay. Centralized fact. Okay. Serial number. Okay. File name. Owner. Okay. So permissions. Then size. Okay. So then okay. Permissions. Okay. Timestamp. Block size. Okay. Block numbers. Okay. This is one. Okay. Serial number 1. What is the name of the file? Here. Sample1.txt. Owner Venkata. Who has written this? Owner Venkata. Permissions read, write, execute. Okay. And time. Okay. Block size 128 MB. Okay. Block numbers. Okay. It will write the block numbers. All these 4 block numbers. Clear?
Yes, sir.
Now, centralized fact okay, has the metadata. Okay. So this is information about your file. Okay. This is your actual data of the file. Name node will update the centralized fact. Got it? Okay. So now if you see the architecture part here, so this is the name node machine. Okay. This is the server which is running with name node service. These are the servers which are running with the data node services. Okay. And name node is the one who is maintaining the metadata. Okay. In its storage. And data nodes are the ones who are maintaining the blocks. These small okay, white ones are blocks. Okay. Blocks in the data nodes. Okay. So, and okay. Metadata operations. Okay. Client actually. Okay. When I say who is client here? So client is nothing but your writing algorithm and reading algorithm. These are the clients actually. Okay. So here, okay, writing algorithm or reading algorithm. Okay. So client will connect to name node. So whenever, okay, you want to write a file. Okay. So as a user, as Venkata, the user, you will type the command and press enter. In the background, okay, writing algorithm will be invoked to name node and ask, okay, name node, I want to write this file. Okay, so now name node will check in the centralized fact, okay, whether this same entry is available or not. If no, then okay, name node will confirm writing algorithm. Okay, start your process. So now writing algorithm will cut the data into pieces. Okay. So now, okay, once it is done, okay, now writing algorithm will ask again name node, hey, I have these many pieces. Tell me what is the name I should give for each piece and okay, where each piece should be stored. Okay. So now name node will decide, okay, what is the name of the piece and okay, what is the where it should be stored also, in which data node it should be stored. Okay. Now how name node will understand, okay, which data node should be stored, because each data node is sending heartbeat to name node and okay, they are updating like, okay, how much free space each data node, okay, each data node is having. So name node has this information, how much free space is each data node is having. That information is already with name node. Based on that information, it will decide block 1 should go to these 3 data nodes, and block 2 should go to these 3 data nodes, block 3 should go to these 3 data nodes, and block 4 should go to these 3 data nodes. Name node will decide. Okay, so based on the name node decision, so writing algorithm will cut it. Okay, writing algorithm will just follow it. Clear?
Yes, sir.
Okay, so just follow it. Okay, and it copy the data blocks with the help of data nodes in the respective hard disk. And now, okay, it will confirm name node service. Hey, name node service, my work is done. Okay, now name node service will update the metadata in the metadata file. This is the metadata file, centralized fact file. Once done, then okay, writing algorithm will be closed. So this is how it will work. So now in Hadoop architecture, we understood there are 2 major services. One is name node, which is the master service, and data node, which is a worker service. Clear?
Yes, sir.
Okay. So I guess okay, we can stop it here, guys. We can stop it here. Okay. So what next? What next? So guys, okay, as I promised you, okay, I have given you demo class. This is free. Okay. Class 1, 2, 3. So I have given all these 3 for free. Okay. So by this time, okay, you might have understood. Okay. So how I am teaching. Okay. So how I'm answering your questions. Okay. Whether the concepts are clear or not. Okay. Whether I have knowledge on the concepts or not. Okay. Some people will talk without knowledge also. Okay. Whether I have knowledge on concepts or not. Okay. So you might. So now it's time for you to think. Okay. What to think? What to think? Whether to continue this course or not. Okay. So okay, as of now, what is happening? Okay, when you use that link, okay. So what is the message it is showing? Like you are in the waiting room, right?
Yes, sir.
Normally, when you log in the morning, okay, what it will show when you click in the this one. So you will enter into waiting room. Okay, you'll be in the waiting room. Okay. Okay, is allowing whoever is there in the waiting room. Venkata is allowing. Okay, so I'm allowing whoever is there in the waiting room, so that okay, you all will be able to listen the class. Okay, but okay, going forward, what will happen from tomorrow onwards? Okay, if you want to listen, okay, if you are in waiting room, I will not allow you. Okay, but okay, so but okay, how to enter the class? Okay, without waiting in the waiting room. Okay, so now you decide. Okay, so I'm going to make the payment by end of week. Okay, make the first installment. As I promised, okay, first installment is 10,000 minimum. Okay, so this should be done by end of today. Okay, so this should be done by today, and okay, next installment should be okay. So then okay, once you make the payment, okay, so you send the screenshot to me, to my okay my WhatsApp number 9342. Okay, so to this number, okay, so you send me. Okay, so before that, okay, so you need to make the payment. Okay, if you want to make the payment, you need the details actually to which Google Pay number or Phone Pay number you need to make. Okay, so the Google Pay number, Phone Pay number, okay, I will share me in WhatsApp. WhatsApp for payment details. Me in WhatsApp for payment details. Okay, so now okay, I will share. Okay, so I will share the details. Venkata will share. Will share the details. So now make the payment. Then okay, once done, okay, send the screenshot. Screenshot your email ID and your okay contact number, WhatsApp number. You send these 3 WhatsApp number. Okay. So now okay, if you send this one, what I will do? Once okay, I confirm the payment, then okay, I will add your Gmail ID too. Okay. Now, okay, so Venkata will add your Gmail ID to Zoom. Now, okay, you will receive a mail. Once done, you will receive a mail from Zoom. Okay, and activate. You will have to activate the link. Okay, so this is the process. So once you make the payment and share the screenshot Gmail ID WhatsApp number, then I will add this Gmail ID to Zoom, my Zoom account. Okay, so when I add your ID to Zoom account, Zoom will send a mail to you, activation link. Okay, so using this activation link, okay, you will have to activate. Okay, you will have to activate the link. Okay, once activated, okay, so then your Gmail ID will be added to my Zoom Hello users list. Okay. So whoever is part of this Hello users list,
Venkat, is there any WhatsApp group for this?
I will create, sir. I'll create. So
Okay.
I'm taking this WhatsApp number for that one. Okay.
Yeah, Venkat, this is Vipin here.
Yeah.
Venkat, today actually I did some cleanup in my Gmail.
Okay.
Maybe if by mistake I deleted that Zoom activation link. I don't know
No,
because whether you added or
I
not.
guess I don't know whether I sent it or not, but however I will send it again, sir.
Okay, okay, sir. Thank you.
We'll add you to the class WhatsApp group. This is the last step. Okay, so this is the process, guys. So make the payment. Okay, send me the screenshot Gmail ID and WhatsApp number. Okay, so I will add your Gmail ID to Zoom. Okay, Zoom will send the activation link, and okay, you activate your link. I will send all the instructions. Okay, how to activate the link and all. Okay, so then okay, your Gmail ID will be added to my yellow users list. So whoever is there in the yellow users list, only they can join the classes from tomorrow. The rest of the people cannot join. Okay. And okay, so once you make the payment, okay, then okay, you are giving the WhatsApp number, right? I'll add your WhatsApp number to the class group also. Okay. Clear, guys? Okay, so that's all I have from my side. Okay. So if you need payment details, okay, just ping me in WhatsApp. Okay, my number is 9342. Payment details. Okay, this is the number. Okay. 70700. Okay, you ping me on this number. I'll share the payment details.
Sir, this is Amit here. Sir,
Yes,
for
sir.
me, do I need to again reactivate the link?
I guess yes, sir. Okay, I've deleted all the old employees. Old students link actually. Okay, so I will send the link to you, sir. Okay.
Okay, sir. Thank you.
Yeah. Okay, sir. Thank you, guys. Okay, that's all I have for today.
Sir, regarding the old class, sir, students, is any
Sir,
update?
okay, so old batch students are okay. So many old batch students are there. Yes. Yes. Okay, 1 second. I'm getting a call. Okay. Sorry guys, okay. So, sir, any old batch students, okay, please ping me separately in WhatsApp. Okay, so we'll, okay. Normally for old batch students, yes, okay, you'll be allowed only after 15 classes from tomorrow. Okay, I will not allow old batch students from tomorrow. But okay, there are some exception cases actually. Okay, so these exception cases joined late, very late. Okay, and they want to. I promised them that. Okay. So these exceptional cases, okay, they joined late actually in the last batch. So I told them that, okay, I will give a chance to listen from starting. Okay. The exceptional cases I'll allow from tomorrow. Exceptional cases of old batch students, okay, will be allowed from tomorrow, but not all old batch students. Okay. So if you're an exception, please ping me in WhatsApp. Okay. I'll see and I'll make the necessary things actually. Okay. Otherwise,
sir.
okay.
Thank you, sir.
Otherwise, normal old students, okay, you will be allowed only after 15 classes. And guys, okay, so if you feel the training is good and okay, the concepts are good, or okay, your understanding, okay, so everything is good means, okay, so if you still feel okay, you can refer some students, okay, you can refer. I will share the completed class videos with them. If anybody is still interested, okay, any of your friends missed first 2 classes, now they want to continue from today. Tomorrow, yes, they can continue. I'll share the missing class videos. Okay. So thank you guys, and okay, it is a see guys. Okay, I'm in few things I'm very strict, guys. Okay, so my class timings I'm very strict. Okay, and the fees also very strict. Okay, so only the people don't think that okay, Venkat sir will allow everyone okay tomorrow also. No. Okay, even one person made the payment, I'll take the class for that one person only. Okay. Clear? Thank you guys, and I can see you all tomorrow. Thank you.
Thank you, guys.